Hi there, this is Weather Analysis with Mr. CB, and we're back with another lesson. So, we're going to still be talking about winter precipitation. So, first, let's talk a little bit more about freezing rain. So, there are three ways that freezing rain can form, and we already talked about this some in the last video, but you can have total melting of the ice crystals, um, and it's too warm to refreeze. So you can see what happens. There's snow, and then it melts completely, and then it reaches another cold layer where the raindrops become super cooled. And then you can also have a case where the sounding is above freezing all the way except at the surface. So maybe it was red all the way, so it would be over all the way, but then at the surface it's freezing. And then the sounding is below freezing, but it's not cold enough for snow, and you can have rain instead. We'll talk more about later in the video that some misconceptions that can occur with when snow may or may not form. So some important concepts. Raindrops do not freeze easily except with the presence of nuclei. So we're going to talk more about that later about ways that the freezing will occur. Snowflakes do not form just when temperatures reach freezing, unlike you might think. So we have in the upper levels of the atmosphere, it needs to be -10, and really -12 to -18 is where we have dendrite growth zone. Um, so there's some forecast methods where we can look at the thickness of layers of the atmosphere. So what this really means is we have a certain level in the atmosphere, um, and the thickness values are telling you how thick that is, like that layer of the atmosphere, and that can help us know. Um, for thickness, that you can represent thickness in terms of the pressure levels and meters, but one important thing is if you might hear the 540 line, if the that would be 540 decameters or 5,400 meters. Um, that's gonna help you know where the rain snow line is on a map. So if you see that level of 540 um on a map, that might tell you where the rain snow line is. But as we see here, we can use these thickness values to help determine the rain snow line, but we should also look at the soundings. That's very important. All right. So then some vocab here, I guess. So the PBL, planetary boundary level. It's the lowest level of the atmosphere, and it's what's still influenced by the Earth's surface. And there are going to be some different things that happen in that level compared to other levels. We have super adiabatic lapse rates, which are any lapse rate that's greater than the dry adiabatic lapse rate, which remember is 10 degrees Celsius. Um, and we have some rates that are greater than this. Outside of the planetary boundary level, these lapse rates are typically dismissed, but otherwise, if they are in the level, we know that we have unstable situation, because the environmental lapse rate is greater than or less than this large rate. So the environment is cooling very quickly. Um, And if we have a situation that's isothermal, we can have the environmental lapse rate that is exactly against a temperature line. Pure water does not actually freeze until -40 degrees Celsius, but supercooled water often freezes before reaching 20 degrees Celsius. So if we're looking at what we have in clouds, we can have uh, uh, changing with temperature, like at zero, it's still going to be an all liquid cloud. That's might seem contrary to what you might think, but we're going to have an all liquid cloud if it's at zero. And to get to a situation where it's all ice, it has to be look like almost -35. So that's an important thing. There are three ways that an ice crystal can grow that we can talk about. We have deposition, which is going from a gas to a solid. We have accretion, also known as riming, and aggregation. Deposition occurs as water goes from a solid to a gas, or gas to a solid. Sorry about that. That's reverse, because this we're talking about ice crystals forming. So from a gas to a solid. This causes the relative humidity to decrease and the surrounding water droplets evaporate to replenish the lost water vapor. Um, the ice crystal growth is dependent on the evaporation of liquid droplets, and then once the ice crystals form, they fall due to gravity. So the air ends up becoming supersaturated, and all of the water molecules in the air that evaporate, they end up collecting on the ice crystals. The ice crystals break as they fall and pull more water towards them, which causes them to grow and go form into snowflakes. We have accretion, which is also known as riming. This is ice crystal growth through the collision coalescence process with supercooled water. This occurs from -10 to 0 degrees Celsius. It occurs with warm clouds and drops of different sizes. Water drops of different sizes collide and coalesce. If they're the same size, it doesn't work because their differing sizes causes them to fall at different speeds, which is why they collect and coalesce, combine. No ice crystals are involved with this process initially. Essentially, the raindrops are colliding and coalescing. That's why it's called that. And this is what accretion is. Um, it more often occurs near 0 degrees Celsius. But they will eventually freeze and become ice crystals. Aggregation is just ice crystals sticking together, and this happens from -5 to 0 degrees. Heterogeneous nucleation helps us to understand, well, I'll just say the definition, the process by which ice crystals form from liquid water um, molecules because they collect and freeze onto foreign particles such as dust, clay, or aerosols. Ice crystals do not activate until -10 degrees. So that's what I was saying before. And silver iodide, which is used for artificial cloud seeding, just needs to be -4 degrees Celsius. Sounding analysis. So if we're looking at a sounding, um, and we've talked about these soundings a lot, but what is the order of the steps of what we should look at? Well, the first thing we want to know, does the sounding even support ice crystals? Is any of the sounding in the dendritic growth zone, the DGZ, which is -12 to -18 degrees? Look to see if the line goes into that range. Next, is there even enough moisture? You need approximately 70% relative humidity, so the dew point line needs to be close to the environmental temperature line. Next, you need to see if any of the sounding is above freezing. If so, where is this layer? Is it a surface layer or elevated melting layer like we talked about in the last video? If it's at the surface, how big is the layer? We're going to talk about this later. The elevated melting layer, how big is it? What's the maximum temperature? What is the thickness? What are the characteristics of the layer under it? We're about to talk about all this. But first, some more important considerations. I already said this. Snowflakes do not form when temperatures reach freezing. Activation is needed, which is typically more at -10 degrees Celsius, not 0. Entire clouds under freezing may not even have ice crystals. Remember, we looked at that kind of bar graphs. It might need to be closer to -35 for it to be all ice crystals. Some specifics about the elevated melting layer for temperatures that you need to look at. Is the maximum temperature less than 1 degree Celsius? Well, then minimal melting will occur, so you can likely think that snow will still happen. If the maximum temperature is greater than 3 degrees Celsius, complete melting is likely. So you'll have either rain, freezing rain, or sleet, depending on the thickness and of the layer, thickness of the elevated melting layer and the layer below. We talked about that in the last video some. Um, and if it's between 1 and 3, partial melting will occur, but still we don't know if it's going to be rain, freezing rain, or sleet. That depends on the other characteristics. For the thickness of this layer, if it's between 1,500 and 4,000, we'll have partial melting. If it's greater than 4,000, we'll have complete melting. For the surface melting layer, if the layer is the top of the layer is 900 feet up, we'll have limited melting and snow will still be likely. So it's not a big enough layer for complete melting. But if it's greater than 1,200 feet, total melting will occur and we'll have rain. Now, the temperatures of this layer helps us to know what specific mixed precipitation we could have. Minimum temperature less than -5, sleet is possible. If it's between -5 and -2.5, we'll have probably a combination of sleet and freezing rain. If the minimum temperature is less than 2.5 degrees negative, freezing rain is likely what we'll have. Important note. If complete melting occurs, sleet may still occur if the minimum temperature of the freezing layer is less than -8 and the sub-freezing layer is less than 3,000 feet. So what we're saying is there are situations where the ice crystal will completely melt and it could refreeze into sleet. All right, that's going to be it for this video. Thank you for watching.